professor. My name is Ban Binji and my student ID is B6130503. So today I'm gonna explain the final examination for the video part, and I'm sorry again for my device that it doesn't have a camera because my device don't have it, so I'm sorry about that. But I'm gonna explain the final exam by myself. Yes, hopefully, and hope you can recognize my voice. So let's move to the first question. The first question, the final exam. So we have the whole transfer function here, and this is what we got from the instruction of the exercise. So they asked us to design the composite or controller for the system. First, before move into the design, we need to find the transfer function first. So as we see here, first we have to consider it as a forward open loop, and from the function here we can find the value of the function forward open loop here. ts equals gcs multiplied by 1 cs square, the function here, and then we consider on feedback loop and then we sum up all the loop to be data s, and when we substitute all the value here, we will get data s equal to this number, and then finally we can find the transfer function, which is equal to ts over data s, and then we must multiply this one with the controller here, and when we substitute all the value, we will get the transfer function here, ts equal to 1 over 50s multiplied by 2s plus 6.25 and multiplied by the controller. And then after we got the controller, we can design the controller or capacitor according to what we want, which is ts equal to 0.5 seconds and overshoot less than 20 seconds or 20%. And in this step, because our purpose is to define the function that has testing time and overshoot less than 20%, so I'm gonna just read compensator by using the roller cost design or roller cost design. So this is the formula for the lead compensator. So we got 20 overshoot is 20%. So from overshoot we can define the damping ratio equal to 0.44559, and then we can also obtain omega n from the settling time, which is equal to 17.55 radian per second, and then we can obtain the desired pole from this value, and when we substitute all the variable into the function, we will get s equal to h, and this is j. And then next step, we need to plot all the pole of our transfer function in the graph, and we have two pole, which is s equal to 0 and s equal to minus 3.125, and we plot here, and this is our two pole, and then we need to add 0 and pole in the graph. Assume as pole and 0 here, so we can calculate the angle of each pole on the graph, and we obtain this formula, and we got each angle, and then we obtain this formula, and we will get the relationship between phi z and phi p equal to 44.45 degree, and then we assume that the z equal to 9, and then when we got the number value of z, we can obtain phi z equal to 86.64 degree, and then we get phi p equal to 41.89 degree. And then after that, we can obtain p from this from pp, and then we substitute all the value into the function, and we try to plot this function with the our first function gs multiplied by gc into the root cost, and we try to find k on this one. Then we can find this one, and after that we plot the standard response, and we got over s overshoot is over 20%, and which is not good, but ts is okay, so we need to redesign again. And thank you so much.